In this last video, we're going to be talking about finding powers of I. So anything higher than the 1, 2, 3, 4 we've already talked about. But let's just review. We know I is I. I comes from square root of negative 1, but we're going to write it as I. We know that if we square both sides, we get negative 1. We've talked about that in previous videos. Same thing with I cubed. I cubed is just I squared times I. So negative 1 times I is negative I. Then I to the fourth, well, that's just I cubed times I. So I end up with negative I times I, but negative I times I is negative I squared, and I squared is negative 1. So we have a negative 1 times negative 1, which makes a positive 1. So we talked about that in a previous video. We went through 1 through 4. But now I have I to the fifth. That's the same thing as I to the fourth. That's a 4 times I, right? 4 here, 1 more makes 5. We know I to the fourth is just 1 times I. And 1 times anything is itself. So that's where I to the fifth equals I. If I did I to the sixth, well, that's I to the fifth times 1 more I. And we just found out that I to the fifth was I. So I'm going to write I times I, which I squared we know is negative 1. I to the seventh, we have I to the sixth times I, and I to the sixth we just found was negative 1 times I will give us negative I. I to the eighth, well, that's I to the seventh times I. We just found I to the seventh was negative I, and negative I times I would be negative I squared, but I squared is negative 1, and negative 1 times negative 1 is a positive 1. Do we see a pattern here? It goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. Those are the only possible solutions to any power. I, negative 1, negative I, or positive 1. And in fact, every multiple of 4 exponent gets us 1. Multiple of 4, multiple of 4. And we're going to use that to simplify our powers of I, because we don't want to keep listing it out to 50. You know, if I want to know I to the 50th, I'm not going to list out all the I's until I get to 50. We see a pattern. We're going to use that pattern to simplify. So it's the multiples of 4 that get us to 1. We can't say anything about the multiples of 2 because the multiples of 2 include multiples of 4. So don't try to use this because when I go 2, 4, 6, 8, 2 is negative 1, but 4 is positive 1. So don't use that. And don't use the multiples of 3 because we can see here, if I have I to the ninth, that's a multiple of 3, but I got I. I didn't get negative I, like this multiple of 3. The only thing that's really consistent forever are the multiples of 4 are always going to be 1. Okay? So down here, if I want to know I to the 13th, I want to know the closest multiple of 4 that's less than 13. So I can split that I to the 13th into I to the 12th times I. 12 plus 1 more would give me the 13. But I to the 12th is just 1. And 1 times I is I. And there you have it. I to the 40th, well, 40 is a multiple of 4. So that's just 1 right away. Any multiple of 4 is going to be 1. I to the 50th. All right. So I to the 50th, the closest multiple of 4 that's less than 50. I'm going to say I to the 48th. So if I'm using 48, that means that there's 2 left over. It has to add up to 50. And I to the 48th is 1. Any multiple of 4 with the exponent there is going to be 1. And I squared is the same thing as negative 1. So 1 times negative 1 will give me negative 1. Now I've got a negative exponent here. Don't be tricked. What do negative exponents do? They take the reciprocal. So 1 over I to the 10th. Now there's a couple things that you could do here to rationalize this. Again, you don't want that I in the denominator. So you could choose to simplify that I to the 10th on its own. Or, in my opinion, we want to get to a multiple of 4. Because a multiple of 4 is going to give us 1. So I have to add how many i's to make 10 a multiple of 4? Or, well, not 10 itself, but how many more do I need to add to get to a multiple of 4? Did you guess I squared? And whenever we do the denominator, we have to do the exact same thing to the numerator. So now I have I squared over I to the 12th. And I'm going to come down here. I squared is negative 1. I to the 12th, that 12 is a multiple of 4, so it's going to be just 1. And negative 1 divided by positive 1 would give us negative 1. Alright, I want you to try E, F, and G. Let's see how you did. Alright, part E, we have I to the 38th power. What is the closest multiple of 4 that's less than 38? Did you choose I to the 36th? Then that means that there's 2 left over to get to that 38 that we started with. And we know I to the 36th is going to be just a 1. And then I squared we know is negative 1. And 1 times negative 1 is negative 1. What about I to the 25th? Closest multiple of 4 would be I to the 24th. And so that means there's 1 I left over to get us to 25. I to the 24th is 1 times I is just I. And the last one here, it has a negative exponent. Negative exponents take the reciprocal. And then I ask myself, what do I have to multiply by to get it to a multiple of 4? So 22, I would need to add 2 more. So I do I squared times I squared. And I'll have I squared in the numerator over I to the 24th. I squared is negative 1. I to the 24th is a positive 1. And negative 1 divided by positive 1 is a negative 1. And that's as far as you can go. And I'm noticing there's kind of one that's missing here, so I'm going to add one. Let's do I to the 35th. Okay, I to the 35th power. What is the closest multiple of 4 that is less than 35? Did you guess I to the 32nd? So 4 times 8 would be 32. That means I have I cubed left over, right? I to the 32nd, that 32 is a multiple of 4. That's just going to be 1 times I cubed. But we don't write I cubed, we write negative I. So 1 times negative I, 1 times anything is itself, we end up with negative I. So again, our 4 possible answers for any power of I are 1, -1, -I, and 1. So I is just itself, I. We have to know I squared equals -1. We have to know multiples of 4 give us +1. And so that leaves I cubed to be -I. You do have to memorize those or be able to find them by going through this process and recreating how to find the next power of I. You just need to know it for the first 4, and then we can use this process for anything bigger.